is a circle. A circle completely surrounding the upside down.
Oh yeah? And how exactly do you figure that?
Because unlike you, I didn't sleep through Algebra 1.
Trust me, I know you did too, so let me catch you up to speed. If you see Dustin's drawing, you see that there's a circle with a triangle inscribed in it with the vertices touching on all the outsides. What he's trying to find is the center of the circle using something called the circumcenter. The circumcenter is essentially a process in math where we take the perpendicular bisector of each side of the triangle and the intersection point becomes the center of a circle. So the first step that I'm going to do is I'm going to find the midpoint of all the sides. The way that I do that is I add up all the x values and then I divide them by 2, essentially finding the average. You should get at least 2 points that look like this, directly in between both of the segments. From there, I'm going to find the slope of both of these segments and then find the opposite reciprocal slope, in other words, the perpendicular. So after subtracting the difference between the y values over the distance between the x values, the slope formula, I get 1/2. Now for me to find the perpendicular one, I just flip it upside down and make it negative, so in this case, it's going to be -2. After finding the midpoint and taking the slope, I put them into point slope form to find the actual perpendicular bisectors. Now what I'm going to do is set them equal to each other to find that center. So after you set them equal to each other and solve, you're going to get this point right here, which is the circumcenter. Essentially what that says is that the distance between this point and all these vertices are the exact same, making these radii, which proves Dustin's theory that in fact there was a center and they were in a circle. Hope that helps.